So this is what they talk about the head foot. This is a modified foot. It's modified into these arms, which are the shorter ones. You got about 8 of them. And then you've got usually 2 longer tentacles. These have been a little bit clipped off, but they have a little bit more reach. And of course, these are predators. You know, these guys run around. Some of the bigger squid, of course, these guys get over 50 feet long. Some of the giant squid, they found evidence that they eat like baby sperm whales. So that's pretty good for a mollusk to be catching and eating, you know, a mammal. But they do it with these arms. They're grasping, very muscular. And if you look underneath, you'll see all these suction cups underneath for grasping prey. If you look at the big ones, like if you ever get to like the Smithsonian, they have a big one and a big tub of formaldehyde. It's like a 30, 40 footer. Inside the suction cups are also these huge, you know, keratinized hooks. They're nasty looking things for grasping prey, large prey, and eating it. So those are the arms and tentacles. In the middle of this mess, the buccal cavity, this is its feeding structure. It's really cool. I'll pull it out first, but this is the beak. And if I can get it removed, it looks, there we go, it's pretty soft. It looks just like a bird's beak. You know, convergent evolution, are not really related. There, I broke off the keratinized bit. But these are very hard, you know, keratinized protein. Let me see if I can get them together. So they kind of go together just like a bird's beak. Those are the 2 halves. It's hard to get them on the field of view, but very sharp. These things, like octopus, which have the same setup, they eat crabs and lobsters, and they can rip right through the shell with these sharpened beaks. But that's a beak for tearing flesh or shells or what have you. 2 halves of it works just like a bird beak. This part, that I can stick my finger in here, this is called the mantle. It's big and muscular. All the mollusks have a mantle. It's in a clam, it's what lines the shell and secretes the shell. Of course, these guys don't have much of a shell left, just remnants. But you'll see some fins at the posterior end. These are muscular. So for slow speed swimming, they'll use these fins, kind of wiggle them back and forth, they're almost all muscle, and that'll drive them through the water at a fairly slow rate of speed. Now, what else they can do that's kind of cool, of course, all the cephalopods have jet propulsion as well. So I'm going to cut through the mantle here. Like I said, it's a pretty thick, muscular mantle. Here's the head foot. Now what happens, of course, there's an opening here where water can flow in this direction. It's just a loose collar here, and it will fill up this mantle. There are a couple of valves, these little things. You can see a piece of them here and a piece of them up here. This is a valve. So normally it lets the water in, kind of comes in this direction through the valve, fills up the mantle. If these things need to escape in a hurry, what they do is they constrict this mantle around sort of the head foot. They squeeze it and pressurize it. That pressurizes the water tremendously. And then there's a little funnel right here. I've got the forceps through it, so that would be sitting there like this. So when they squeeze this mantle, the water shoots out of this funnel, and it's basically jet propulsion. So that's the funnel you have on your sheet, I think. That's where the water exits at high speed. And on either side, these old ropey looking things, these are funnel retractor muscles. It allows these things to steer, basically. They can kind of go left, right, and they'll turn that funnel any direction they want. Let me stick a probe in the funnel if I got one. Not a good one, but. So the funnel's right here, forceps coming out of it, and the retractor muscles can just move. So they can move where that funnel discharges the water, and it moves them backwards at a pretty high rate of speed. There are even some squid they call flying squid. In an emergency, they go fast enough, they'll exit the water, to clear or get away from predators. So that's the mantle. And if you open it up, these guys have pretty big gills. You'll see one right here, one on each side, big set of gills. Now the heart, you may be able to see the heart. We haven't talked about circulatory systems yet, But squid have a circulatory system, and all the cephalopods. It's comparable to our own. It's called a closed circulatory system. That means it delivers high pressure blood at high flows of the tissues. These guys have to maintain a pretty high metabolism because of their lifestyle. So they actually have a series of hearts. We have the same thing. Ours is just in the same spot, the left and right side. They have a main heart, and then without the injection, it's hard to see, but at the base of each gill, so here's a gill, if you go down to its base, right about here, there's a little branchial heart. It's an accessory heart. So one pumps blood to the tissues where the pressure drops, then it comes back to this heart, which pumps it again through the gills. It's a way to maintain high pressure and high flow in their circulatory system. They actually have a circulatory system, functionally it's comparable to our own. Then right below this siphon where the water blows out, so here's the siphon. I'll put the forceps through it right here. Internally, this thing right here, it's usually staying a little darker. There's two tubes coming out right here that are basically going to get carried out with the excurrent water. There is an ink sac and a rectum right here. Let me see if I can separate them. Sometimes they come out together. That is the ink sac. You can tell by the color. And I think I've got part of the rectum with it. The ink sac, of course, what these guys can do, they also have a lot of chromatophores, sorry. They can change the color of the skin on demand. It's controlled by the nervous system. And if they're attacked by a predator, what they'll often do is turn themselves really dark, almost black, and they'll swim away at high speed. Predator chases them. Well, predators kind of get target fixation, following a dark thing. Then what they'll do is they'll contract this ink sac, and let me see if he's got any ink in it. He should, because he's fresh. Yeah, it's all full of black ink. They contract that ink sac. It shoots out with the discharged water as a big black cloud. Then what the squid or octopus does, it changes its color to light, and it turns at 90 degrees. The predator sees that white thing go, but it doesn't make the connection. It heads for the big black, mess. Yeah, there's the ink. It's nice and black looking. I think a few places they used to use it as dye. The funnel is right next to the rectum is right next to the ink sac, so of course fecal matter is going to be taken out with the discharged water as well. Let's see the other thing. So you got the mantle, got the gills. Behind this, let me pull him out. Mollusks, evolutionarily or ancestrally, they had a shell for protection. Most of the cephalopods have reduced or lost it. The exception is the nautilus, which is the most primitive of the group. Most of the others, like octopus, have no shell at all. Squid, it's a very small remnant, and it's all internal. Let me pull this guts back a bit. Here it is right here. This thing stuck in the mantle. That's what's left of its shell. There's no calcium carbonate on it. It's just protein. They call it a pen because superficially, it looked like an old quill pen or something. It looks a bit like a feather. That's the pen. It's a little bit of an axial support. Octopus have lost it entirely. Is anyone familiar with cuttlefish? Yep. I don't have any specimens. They have an internal shell. It is calcium carbonate. They use it for flotation. You can buy the shells at the pet store. They use it as a calcium supplement for birds, for example. Cuttlefish looks like a squid. It's just kind of a fat-bodied looking squid. What else is on your list? I think that might be almost everything. I need the terms I got on there. That diagram's just generic. So we got arms, tentacles, beak, pen, mantle, gills, branchial hearts are the one at the base of the gills, funnel retractor muscles, ink sac, rectum. That's about it. So I'll leave this one out. And let me grab a clam real quick. They're a lot easier, not much to clam. Yeah, same body type as a squid. It's just been modified highly. Here's a bivalve. The mantle is this thin, flimsy membrane that encases sort of all the guts there. That's what secretes the shell. So it doesn't do much except secrete the shell. It's a very delicate membrane. Here it is here. That's from the other side. The foot on these guys, This little muscular bit here, that's the foot. If you eat clam strips, that's usually what you're eating, that little bit of muscle right there. These are for digging. These dig into the substrate and just filter feed. So that's the foot. There's a big mass of tissue above the foot, this big bulge here. That's just referred to as the visceral mass. It's all the guts and gonads are in there. So you got the foot, visceral mass, you got the mantle. The adductor muscles are just what open, or what close the shell. These shells will open automatically because of a hinge ligament. They use a muscle just to close them. So there's a big disc of muscle. You can see it right there, that dark oval looking thing. That's an adductor muscle, and there's one on the other side somewhere. Most of it's gone. There's a bit of it here. So that's the adductor muscles. There's usually two. And they are filter feeders. So if you look at the gills are huge. All this is gill in here. Lots of layers of gills. Little striated bits here. They're very thin. A lot of them. That's gill. They don't need that much gills to get oxygen. Again, the metabolism of these guys is pretty small. The gills are also their filter structure. So they pass water through it. Not only to get oxygen, but suspended material is picked up by these gills. And it's moved. There's a good one there. Oh, this side is more intact. There's gills there. Got two layers, one there, one there. So the food is picked up by the gills. They have ciliary tracts in it that move the food forward to the anterior end. And these little triangular things right here, those are called labial palps. They basically process the food. They take the sand and throw it away, and the edible bits they move towards the mouth, which is right up here in front of them. But those are labial palps. You got gills. The visceral mass right under the gills, that lump right there. You got the foot, mantle, and adductor muscles, and then of course just the shell. And I think that's about all the parts I have on that one.